Hello and welcome. My name is Daniel, and today I'll be teaching you the coding essentials, an intro to Scratch. This will be the first lesson in our series of Pixel Pioneers 2026. An introduction. Welcome. Today, instead of just playing games, we're going to become game creators. Today, we're going to learn how to make our own games or animations using Scratch. By the end of today, you'll know what is Scratch, how to use the Scratch workplace, what coding blocks do, how to move a character on the screen. But to introduce us to Scratch, what is Scratch? Scratch is a free programming language created by MIT, otherwise known as the Massachusetts Institute of Technology, that helps people, especially young children, learn how to code. With Scratch, you can create games, animations, stories, music, and interactive projects. Scratch uses colorful blocks that snap together like Lego bricks, so you don't even need to worry about typing all those complicated codes. But what is coding? Coding is giving your computer a list of instructions to follow. Think of it as using a recipe to bake cookies. You have to be specific or you'll end up creating mistakes. Coding, like a recipe telling a baker how to make cookies, tells a computer how to operate. For examples, moving forward, playing sound, waiting a second, asking a question, or repeating an action. Computers only do exactly what we tell them to. So if we aren't specific in our code, it's going to lead to mistakes that weren't seen for. But every mistake is an opportunity to learn after all. Where is coding used? Coding is used everywhere. People use coding to create video games, phone apps, websites, robots, self-driving cars, medical equipment, space missions, online shopping. Basically, anything that requires technology that you can think of, coding is used in it. Even the most basic things, like a basic talking action figure, coding was used there. Learning to code helps solve real-world problems as a very valuable skill. Now, point 1, meet the Scratch workplace. Meet the Scratch workplace. Scratch has several important parts to creating a functional code. It has the stage, where your project plays, the sprite, the character or object you control with code, the coding area, where you build the code, the block palette, where all the coding blocks are stored, and the backpack, where you can store items for later use. Everything you create happens inside the workplace. Slide 6. Motion blocks, which are colored blue. Motion blocks tell a sprite how to move. For example, move forward, turn left, turn right, go to a position, glide across the screen. You'll use these blocks every time you want to move a character. And now, I'll show you all an example of movement blocks. Now, to continue with our live demo, I'll be showing you some basic movement blocks just to get us started. We'll look over more of this in day 2. First, I want everyone to take the Move 10 Steps button. Then, I want them to drag it into the workbench like this. Next, I want everyone to click on the Move 10 Steps button. What do you notice happens? Correct. The sprite moves slightly towards the right. This is because the Move 10 Steps button moves the character or object along the x-axis every time it's clicked. Whenever the value is positive, for example, positive 10, the character, as seen here, moves to the right. But what if we want to make them move to the left? Well, that's also simple. All you have to do is, instead of the value being positive, make it negative. Now watch what happens. The character moves to the left. This is because all negative inputs are seen to the left, while all positive inputs are seen to the right. And to get the character to move more, you can simply increase the value, or decrease it to make them move less. Next, we have the turn button. The turn button, like turn to the right by 15 degrees, or turn to the left by 15 degrees, as in the block description, they turn the sprite to the right, like this, or to the left. Depending on the number, you can either make them turn by a lot, for example, making them turn directly 90 degrees, or make them only turn a bit. For example, turn them to the left by 45 degrees. These can be very useful, for example, making an object repeatedly spin, or making an object turn when facing the player. Now it's time to return back to the slideshow. Now we have the look and sound blocks. Looks blocks, which are colored purple, these blocks change how the sprite looks. For example, it can make a sprite say something, think something, change costumes, show or hide the sprite, or change the size. Whereas sound blocks, which are colored pink, these blocks let the sprite play sounds, play music, or change the volume. These help making your project more fun, exciting, and engaging. Now it's time to go back to Scratch. First, let's look at the look blocks. For example, say hello. The say hello button, for example, makes the sprite say hello for only 2 seconds. But let's say you wanted to make the sprite say something until you told it something else. Then you would use the say hello button. Though these blocks appear similar, they have different functions. Whereas the say hello for 2 seconds button might be used for example, dialogue. The say hello button might be used to consistently have a sprite say something, because the say hello button will always make the sprite say something until the programmer makes the sprite say something else. The think buttons function the same way. The only difference is that instead of a normal text bubble, it's a thinking bubble. We'll get more into the switch costumes buttons and the size changes on day 2. Next, sounds. The sound buttons are used to help add sound effects to your game and make them more lively. For example, did you hear that? Whenever you use a play sound, you're able to select any of the sound effects that are currently within the sprite. For example, in the cat sprite, there's only the meow. So every time the play sound meow button until done is pressed, it'll always make the sprite play its sound until the sound finishes, no matter what. This can be helpful if you don't want your sprite to get cut off randomly. We'll dive more into this along with looks on day 2. Next, let's look at the event and control buttons. The event buttons, which are colored yellow, your event buttons tell your program when to start. For example, when the green flag is clicked, when a key is pressed, when the sprite is clicked. The control buttons, which are colored orange, these control blocks allow you to organize the code. For example, waiting, repeat button, forever statements, if statements, stop statements, or when the green flag is clicked. These can be helpful for having your program to think on its own. Now, let's head back to Scratch. The event buttons. These event buttons help make your code act independently instead of you always having to control it. For example, let's take the green flag button and drag it onto the workbench. Then, let's take, for example, the move 10 steps button, and then let's have it turn. Then, we'll have it say hello. And you know what? Let's make it meow too. And to fit with the theme, let's change this to meow too. Now, notice what happens when you put in this code and click the green flag. Did you see that? They'll happen really quickly. Your sprite instantly move 10 steps, turn slightly more, send meow for 2 seconds while the sound played. And congratulations, everyone. You've just made your first code. As you can see, event buttons like when green flag clicked make it where as soon as this event happens, like the green flag getting clicked, it'll automatically play the string of codes without you having to manually input it. This can also be used, for example, to make simple game controls. Like, let's try to make our sprite move right when the right arrow is clicked. For example, to replicate this code for a simple version, all you would have to do is take when the right flag key is pressed, which is located in vent under the one green flag click button is. Then put in move 10 steps. Now, notice what happens when you click the right flag. It'll always move, it moves directly the way the cat's facing. Now, let's try to make it move the other way when the left arrow is clicked. What you're gonna do is right click the when right flag key is pressed, then click duplicate. Then I want you to click where it says right arrow and switch it to left arrow. Then turn it from 10 steps to negative 10 steps. Now, notice what happens. When the left arrow is clicked, it moves back. Or when the right arrow is clicked, it moves forward. As you can see, simple event blocks allow you to automate your code more efficiently. Now, let's move on to the control section. In the control section, it allows you to, for example, slow down code or make it repeat certain actions. Now, let's go back to our original script. And then, maybe, so that you can see what's happening more efficiently, wait 1 second between move 10 steps and turn, and put it in between turn 15 degrees and say meow. Now, I want everyone to click the green flag and say what you noticed. Do you notice that? Yeah. Instead of being quickly rushed and hard to understand, the wait button allowed us to slow down the code so that we can more easily understand what's happening. This block is crucial for making gameplay enjoyable so that everything isn't just rushed out instantly. This can help make games more enjoyable. Next, let's go to the repeat button. The repeat 10 times button allows the programmer to put this code around any part of their code. For example, you could put it around the whole thing, a few blocks, or maybe even just one block. This can be helpful for making only a certain string of code repeat multiple times without having to click the green flag multiple times. This number can always be changed, like the Move 10 Steps button. Now, let's watch what happens when we click the green flag now. Now, instead of one single meow, the code's gonna make the cat meow 10 times. By doing things like this, it helps automate our code so that we can do more repeated actions to add more engagement in our games. For example, let's say maybe you want to make it where when the character jumps, they move up like 10 times. Instead of having to write it all in one big number, you can instead just make it repeat a certain part of the code multiple times so that it does it by itself. Now, let's look at if statements. If statements are perfect for making the code think by itself. For example, we could have we'll get more into the if statements in the next section. Next, sensing, operators, and variables. Sensings, which are colored blue, in light blue specifically. These allow your sprite to know what's happening. For example, is the mouse touching them? Is the key pressed? Or is a question asked? Operator blocks, which are colored green, allow you to perform math. For example, adding numbers, comparing values, picking random numbers, or creating a score. Variables, which are dark orange, allow you to store information like score numbers, lives, time, and coins collected. Variables help your game remember information. It's like a notepad for your game. Now, let's get back into if blocks and use some of the new types of blocks we learned. For example, first, I want us to get rid of this old code because we won't be needing it right now. And I'd like everyone to reset their sprite's position back to 90. It's a little bit difficult, but barely able to do it. Yeah. Now, I want everyone to put an if blank then block under one green flag is clicked. Next, I want everyone to drag the touching mouse pointer button. Then, I'd like everyone to put it in between if and then. Next, I'd like everyone to go back to looks and put say hello for 2 seconds. Then, on top of all of that, so that always checks, put a forever loop. Now, I want everyone to click the green flag. Now, I want everyone to try touching the mouse. Notice what happens? Yeah. Now, every time the mouse is touching the cat, it'll say hello. You can use this for having your game automatically detect stimuli. For example, when a key is pressed. This can be helpful for the game to know, for example, when to scroll the screen, or when to say hello, or when to play dialogue. Next, I want everyone to stop the game, and then take out touching mouse pointer. Next, I want everyone to replace it with key space pressed. Now, click the green flag again. And like you probably already guessed, now, instead of it being when the mouse is touched, every time a key is pressed, it'll say something. This is better suited for dialogue, but both methods still work. Now, I want everyone to go to variables. Then I want everyone to stop the game, and then go to make a variable. For this example, I want everyone to name the variable score. Next, I want everyone to take away the say hello for 2 seconds and change my variable by 1. Next, I want everyone to put set my variable to 0 at the top of the code. Next, I want you to replace every time it says my variable with score. Then I want everyone to go back to sensing and then choose either one key pressed or with the mouse pointer touching, and then put it in between if and then. For me, I'll just put back one key space press back. Next, I want everyone to start the game again and notice what happens. Notice how the score increased? Yeah, by using something like this, you could make a simple auto click. You can make a simple clicking game with a spacebar. But the only problem is, instead of going slowly, it adds a number. It adds numbers incredibly quickly, which can make incredibly high scores, which are kind of useless. To help fix this problem, I want everyone to go back to control and take a wait block. Then I'd like everyone to set the wait block to 0.1 seconds. Then I would like everyone to lift the green flag again. Now, notice what happens. Instead of increasing a lot, every time it's clicked, it only increases by about 1. While if it's held, it does increase continuously, but it still increases slowly. This is more helpful for making score systems. Next, I'd like everyone to go to the operator section. Then I'd like everyone to drag this block and put it over here. We'll be using it shortly. Then I'd like everyone to go to control, take the if-then block, and put it under the previous one. Then I'd like everyone to drag this green block, put it in between if and then take our little score button and put it right here. Next, I'd like everyone to go to sound and then take the play sound now until done. Then I'd like everyone to stop and restart the game. Now I want everyone to hold it and notice what happens when they reach over 50. The cat always continues to meow. This can be very helpful if you want your game to detect certain milestones after you reach a certain score. For example, unlocking a power-up after you reach a certain score, like 50. This is very helpful for games where you have to collect objects, like if you're trying to make a Mario game with its own mechanic. Now, that's all for today's lesson, and I'd like to give everyone watching this video a challenge. Today's challenge is, I want you to open Scratch, choose a sprite, choose a background, make your sprite move, try changing its direction, and experiment with different blocks. And remember, when coding, there are no mistakes, but only bugs to fix and learn new things. Now, go my Pixel Pioneers, and have fun with Scratch. Have a nice day. Goodbye.